In this section, I will talk about the method of variation of parameters. It's another method to solve non-homogeneous linear second-order equations. So let's consider this non-homogeneous linear second-order equation. A y double prime plus by prime plus cy equals a function f of t. And let y1 of t and y2 of t be two linearly independent solutions for the corresponding homogeneous equation a y double prime plus by prime plus cy equals 0. Then we know that a general solution to the homogeneous equation is given by yh of t equals c1 times y1 of t plus c2 y2 of t, where c1 and c2 are constants. The method of variation of parameters seeks a particular solution of the form yp of t equals v1 of t times y1 of t plus v2 of t times y2 of t. So what you see is that we've replaced the constants c1 and c2 by functions. Now, we must have that the particular solution satisfies the differential equation 1 over here. So let's find yp prime and yp double prime so that we can plug it in here and hopefully find some equations that v1 and v2 have to satisfy that we can solve for v1 and v2. So when we start off with yp prime, we're going to take the derivative of this function here, and so we have to use a product rule twice. So yp prime is v1 prime times y1 plus v1 times y1 prime plus v2 prime times y2 plus v2 times y2 prime. Now, what we want to do here is split this up into two parts. I want to collect the parts with y prime, so y1 prime and y2 prime. So I get v1 times y1 prime plus v2 times y2 prime. So that gives me this part and this part. And then I want to add to that v1 prime times y1 plus v2 prime y2. Now, since we have that v1 and v2 are functions instead of constants, it seems reasonable that we can put some extra constraints on them. So what we're going to do here is we're going to take this part here and we're going to set that equal to 0. So let's make that a little bit smaller. And then we're going to set that equal to 0. Okay, now I've written that down here as equation 4. So that simplifies yp prime a little bit, right? So now with that extra condition, we now have that yp prime is just v1 y1 prime plus v2 y2 prime. So now we can find y double prime. Y double prime is again, a product rule. It's v1 prime times y1 prime plus v1 times y1 double prime plus v2 prime times y2 prime plus v2 times y2 double prime. So now what we're going to do is we're going to plug in these three values, or these three things that we found for yp, and then yp prime and yp double prime. We're going to substitute that into our original differential equation. So I put f on the left, and then a times yp double prime plus byp prime plus cyp on the right hand side. So we have a times ap double prime is this one right here. That's v1 prime y1 prime plus v1 y double prime y1 double prime plus v2 prime y2 prime, and then plus v2 y2 double prime. And then we have b times this one right here. That's v1 y1 prime plus v2 y2 prime. And keep in mind that v1 and v2 are still functions here. I'm just not writing the dependence on t here. Okay, now what we want to do is we want to group this in such a way that we can simplify some things. So I want to factor out a v1 out of every term here that has a v1. So I see a v1 here. So let's take a look at all the terms with v1. I have a v1 here, and I have a v1 here. So when I factor that out, I have an a that distributes here. So I have a times y1 double prime plus b times y1 prime plus c times y1, right? And that takes care of all the terms with a v1. Okay, now let's let's group all the terms with a factor of v2. So we have a v2 here, we have a v2 here, and we have a v2 here. So again, there's an a in front of this, so I have a y double prime, y2 double prime, plus b y2 prime, this term, and then plus c times y2. Okay, and then let's write down what we're left with. So we are then left with a times v1 prime y1 prime plus v2 prime y2 prime, right? And that takes care of these two terms here. And now we've collected everything. Now, how did we choose y1 and y2? Remember that y1 and y2 were the solutions to the homogeneous equation. So in other words, if I plug in y1 into this differential equation, I get 0. And note that that is exactly the differential equation here. So this is 0 and this is 0. So this whole term is 0. And then this whole term is 0. And so we're left with that f is a times v1 prime y1 prime plus v2 prime y2 prime. And we'll continue this in the next video.